Good afternoon, sir.
Good afternoon. So, Vikas, you want to just introduce yourself and for which subject you want to give a snap? Just tell me.
Sir, I want to give snap in strength of material.
So, just give you intro also. है ना?
And my name is Vikas Kumar. I am. I have completed my basic education from my hometown, and then I did my B.Tech in mechanical engineering from Chandigarh Engineering College, Mohali. And then after completing my B.Tech, I prepared for GATE, and on the basis of GATE score, I took admission in IIT Dhanbad for my M.Tech, and and I took admission in mechanical engineering department in a specialization maintenance engineering and tribology. And after completing my M.Tech, I joined a coaching institute, and till now I have been teaching in the coaching institute of GATE. Uh, that's all from me. Thank you, sir.
Okay. So, your area of interest of strength of material also. है ना?
Yes, sir. Strength of material, fluid mechanics, thermodynamics.
Mhm.
These are some
So, what do
subjects.
you mean by Cauchy-Lagrange theorems? Why we use this?
Sir, Cauchy-Lagrange theorem is basically energy conservation theorem, in which which is used to find the slope and deflection in a beam.
Okay, just tell me the formula of that.
So if we have to find the slope, then first of all we will calculate the total energy in the beam due to the load or moment. So for calculating the slope, we will differentiate the total energy with the moment applied, and for finding the deflection we will differentiate the energy with the load applied, point load applied.
Okay. So, what is the difference between when we use a double integration method, when we use the moment area method? How can we decide?
Moment area method we will apply when there is a means the bending, because area method is basically calculated with the help of BMD. So BMD uh, should be linear curve. Then we will go through moment area method to calculate slope and deflection. So means loading will be point load, not a UDL kind of thing. And so that's the limitation of moment area method. And in double integration we can use with the in that type of beam where the boundary conditions are more, because we are integrating, so we will have number of constants, so we will need a boundary condition. So where the boundary condition are more, we will use double integration method.
Okay. What do you mean by resilience?
Resilience is the elastic strain energy stored in a beam.
What is the difference between the resilience, proof resilience, and modulus of resilience?
So resilience is the means strain energy is stored in the beam up to the elastic point, and when we will approach till the yield limit of the beam, means yield up to yield point, the strain energy stored in the beam will be the proof resilience, and below the yield stress or elastic limit, it will be the resilience. And modulus, if we divide the total energy with volume, means energy pollute volume will be the modulus of resilience, and should be within the elastic limit.
Okay. What do you mean by fatigue load?
Fatigue load, sir, means the load is not constant in nature, it is varying with time. So that
What do
is
you mean
the
by endurance limit?
endurance limit, sir. And how much endurance limit is basically the how much no sorry इसके बारे में आइडिया नहीं है सर endurance.
Okay.
इसमें मुझे सर थोड़ा पता है कि फटीग स्ट्रेंथ से रिलेटेड है कि कितना मतलब कितने साइकिल्स तक ये लोड कैरी कर सकता है, बट इसके फर्दर मुझे इसका एग्जैक्ट डिफिनेशन याद नहीं आ रहा सर.
Mm-hmm. Can you tell me how to design a pressure vessel? What are the various factors you are just considering while just design the pressure vessel, just like a thin cylinder?
Can you repeat, sir? What I have to consider?
If you want to just design a pressure vessel, so how can you
Yes.
design the pressure vessel? What are the various stresses you are just considering while drawing the pressure vessel?
Sir, if it is thin pressure vessel, then the actually the uh, two stresses come up. That is the hoop stress and the circumferential stress, in which hoop stress is the maximum stress due to the pressure inside the pressure vessel.
How the hoop is just acting on that? You know? My question is that.
Sir, hoop stress means it is a circumferential stress, and the pressure inside the pressure vessel will try to increase the diameter of the vessel, so circumferentially the stress will come, and that is the hoop stress along the periphery of the vessel.
What is the difference between the SYT and SUT?
SYT, sir, it is the yield strength and SUT is the ultimate strength. If we are applying the load, tension load is applied. And
ब्रिटल मटेरियल में क्या लिमिट लूंगा और डक्टाइल में क्या लूंगा?
सर ब्रिटल में सर हमारा जो SYT है और SUT है वो काफी क्लोज रहता है, और यील्ड में हमारा सर हम जो हमारा डक्टाइल के लिए हम यील्ड लिमिट लेते हैं.
और ब्रिटल के लिए SUT?
सर काफी क्लोज रहता है तो सर कोई भी ले सकते हैं.
अच्छा. सो अगर जो यील्ड पॉइंट में बात करें अपन लोग, तो हमने माइलिस्टो के केस में देखा देयर इज अ टू यील्ड पॉइंट, वन इज अपर यील्ड पॉइंट एंड वन इज अ लोअर यील्ड पॉइंट. व्हिच वन यू हैव जस्ट टेकन व्हाइल कंसीडरिंग?
सर लोअर यील्ड पॉइंट.
व्हाई?
बिकॉज सर ये जो होता है सर, जो इसका स्ट्रेस की वैल्यू होती है वो इलास्टिक माइल्ड स्टील केस में इलास्टिक पॉइंट से नीचे रहता है, काफी नीचे रहता है, मतलब काफी नीचे नहीं रहता, क्लोज रहता है बट नीचे रहता है. और जो हमारा अपर यील्ड और लोअर यील्ड में हम डिस्टिंग्यूश नहीं कर पाते हैं, मतलब तो लोअर यील्ड से हमें इजिली हमें विजुअल रहता है कि ये वैल्यू है. अपर यील्ड पॉइंट सर हमारा इलास्टिक पॉइंट के बाद है तो वो हम ले नहीं सकते हैं, बट लोअर यील्ड है सो जो हमारा इलास्टिक पॉइंट के नीचे रहता है, मतलब जो स्ट्रेस की वैल्यू आती है तो इजिली विजिबल रहता है, इसलिए हम लेते हैं. मतलब कर पे वो इजिली विजिबल है.
Okay. So can you just tell me what do you mean by toughness?
So toughness is basically the how much energy a body can absorb till its fracture. Up to fracture point, how much the energy can be stored.
Okay. So why we use the Mohr circle?
Sir, Mohr circle is basically, sir, is a graphical representation or visual representation of the different oblique planes passing through a point due to the load applied. So we can easily calculate the major principal stress, minor principal stress, maximum shear stress with the help of the circle. where the each point represents the oblique plane. Because to calculate the major and principal stress, there are empirical relation. So it's just a for simplicity, we use Mohr circle.
Okay. What is the difference between the in-plane Tomax and absolute Tomax?
Sir, in plane means, sir, in the plane means if we are considering XY plane, then we will see the how much is the principal stress, like sigma 1, sigma 2. If there sigma 1, sigma 2 is the in plane maximum principal stress, then the in plane maximum shear stress will be sigma 1 minus sigma 2 by 2. So it can be in any plane, xy plane, yz plane, zx plane. But if we are talking about absolute, then uh, we will find out the maximum principal stress in all three directions, sigma x, sigma y, sigma z, and we will see the who is the maximum and what is the minimum. So if we are sigma maximum minus sigma minimum by 2 in all three planes, the whoever the maximum and minimum, then that will give us the actually absolute maximum shear stress.
So while designing, which will we are just considering?
While designing, we will consider absolute maximum shear stress.
Okay. So I will just give you the feedback. Because I think overall you are a good. Your way of delivering is also a good. There is no issue. But a little bit I feel that you are require some revision also.
Okay,
Some
sir.
of the answer is not up to the mark. So you have a knowledge, you are not recall the things. If you are just going to recall the once you are just doing a revision, so your delivering your confidence or your answer is become more appropriate.
Okay, sir.
So please revise the thing. After that, you can just give the snaps once more.
Sir, actually, I have a doubt, sir.
What?
The question is why we have taken the lower yield point as the yield stress. So I'm not sure.
क्योंकि हमारा अपर yield point जो होता है ना वो इंस्टेंटेनियस होता है, वो जस्ट एक पर्टिकुलर स्टैंड पे आता है, उसके बाद वो गायब हो जाता है.
यस सर.
ठीक है.
मैंने सर कुछ ऐसा ही बताया था, तो मे बी सर मुझे लग रहा था कि सही है या गलत है.
किसने?
सर मैं भी वही कुछ बताने की कोशिश कर रहा था, मुझे कॉन्फिडेंट नहीं था कि वो सही है कि गलत है, कि वही इजीली विजिबल है.
Upper yield point is just come at for a instantaneous, so that's why you are not considering the upper yield point.
Okay.
आपने देखा हो एक पर्टिकुलर स्टैंड पे आता है, उसका जस्ट कर्व नीचे आता है, एंड देन दिस इज गोइंग टू बी अ कांस्टेंट.
यस सर, यस. ओके सर.
Okay, thank you so much.
थैंक यू सर.